Okay, and part 4, which is an incredibly difficult question to understand, very difficult to know how to start this question, says that we've got this other circle with a centre at the origin and a radius of r. It says the circle lies completely inside the first circle. What can the radius values be? So it's saying we've got a load of circles like this. It's saying what is the maximum radius that we can have such that it stays inside the initial circle. So we're not allowed something like this, for example, because that's popped outside the circle. Before we answer the question, I just want to explain how we do the very first step to this question. And the first step relies on us understanding that if we've got a circle and another circle inside anywhere, it doesn't matter where we start where the centre is, then these two circles here share a line of symmetry. They have a line of symmetry that goes through both of the centres of the circle. Okay, and you can see that that's quite obvious. But why is that useful to know? It's useful to know because our circle, our initial circle, and the new circle are going to have a line that goes all the way through the initial circle's radius and the new circle's radius. Okay? So this 0.43, which I've drawn completely in the wrong place, but it's just as an illustration, is going to go through our new circle's centre. And we want to know the radius of our new circle. We need to know this length here. But what we already know is that the green line plus the pink line has a length of root 45. We know that from part 1 because that's the radius of the whole of the centre, the radius of the first circle. So the green plus the pink is equal to root 45. So if we can work out the length of the green line and take that away, that will tell us the maximum length we can have for the new circle. And it's quite easy to work out the length of the green line, because if I drop a line down here, given that it starts at the origin and we've got a 90-degree angle here, this length is 4 and this length is 3. So we've got a 3, 4, 5 triangle. This length here from the centre to the from the origin to the centre of the circle is 5. So the maximum length of the pink line is going to be root 45 minus 5. The whole thing, take away the green bit. So when it asks for the set of possible values, r is going to be able to be less than root 45 take away 5. It's also going to need to be greater than 0, otherwise we won't have a circle. So that is the answer to part 4 of question 10. incredibly difficult, only worth 2 marks, a bit ridiculous if I'm honest, but I guess that's the question to stop you from getting 100%. So if you've got the answer, well done, that's very impressive.